Hello, my name is Sam Reed, and for my final project, I created Situational Pitching Behavior, or SPB. Situational pitching behavior is different from most statistics. It is a dynamic statistic tool that allows you to look up how a pitcher will perform in a very specific situation. This gives a deeper, more statistical identity for evaluating clutch pitchers, and also allows users to get a more confident understanding of how a pitcher will perform in high-pressure situations and all situations in general. Situational pitching behavior is also very valuable to batters as it allows them to predict how a pitcher will behave in a certain situation. For my data, I took all of the pitching data generated by StatCast for the 2017 regular season. If a user was to use a larger pool of data, the results would be even more confidently supported. As far as the code goes, the data processing happened in 4 steps. The code first looks up all the data related to the situation and pitcher entered. That data is then isolated or chopped down to only the crucial parts. The isolated data is then processed statistically, and then finally, the code displays all of the statistics in an understandable format. This is all done in a Jupyter notebook, though it could be easily exported to an application. Using the situational pitching tool is very easy. All a user has to do is call the driver function with the pitcher's first and last name, as well as the status of the runners on first, second, and third, which is indicated by a Boolean. When the data is displayed, it will give information about 3 different areas of pitching. The first of those areas is pitch frequencies. Situational pitching behavior will tell the user the frequency of different pitch types thrown by the pitcher in the specific situation outlined, and will display those results graphically and numerically. The second item displayed by situational pitching behavior is the outcome frequencies. The outcome frequencies show the user how likely a pitcher is to throw a ball, strike, or hit into play based on their historical performance in the described situation. The final data shown by SPB is pitch position. This is generated by averaging the location of all of the pitches that the pitcher has thrown in the described situation, and those numbers will be shown graphically and numerically. The position is from the perspective of the catcher, where 0 on the x-axis is directly over the center of the plate horizontally. The y-axis indicates the height of the pitch. The location on the y-axis relative to the batting box can change depending on the height of the pitcher. To show how valuable this tool can be, and to compare it against some ideas that already exist in the baseball world, I decided to do a case study. As I said before, SPB is most similar to the idea of a quote-unquote clutch pitcher instead of any traditional statistics. So I went on MLB.com and found a list of the most clutch pitchers according to MLB.com. I chose 2 of these pitchers, Justin Verlander and Jake Arrieta, and decided to see how they performed when the bases are loaded, which is a very high-pressure situation. So looking at the first result, the pitch frequencies, in this situation, with the bases loaded, the results are very interesting. We see that Justin Verlander throws mostly 4-seam fastballs, while Jake Arrieta throws split-finger fastballs. Justin Verlander also throws very little changeups. This can tell us a lot about what kind of pitches these pitchers are most comfortable with, as those are the ones they're most likely to throw in high-pressure situations. When looking at the outcome frequencies, we see that these pitchers do perform relatively well in this high-pressure situation and could indeed be considered clutch, as they both throw more strikes than balls. When looking at the average position generated by SPB, we see that both Verlander and Arrieta throw almost directly over the plate in these situations. This could indicate that they do not want to try and throw more risky pitches due to the intensity of the situation, so they stay in relatively the same area. In conclusion, situational pitching behavior has a lot to offer for pitchers, managers, and batters. Pitchers and managers will have an increased ability to analyze how a pitcher performs in high and low pressure situations. This can help them work on any mental weaknesses they might have in those situations. Batters are also able to understand the mindset of a pitcher, and they could use this tool on the fly to have an idea of what kind of pitches may be thrown against them when they are going up to a bat in a very specific situation. One change I had to make in this code was to stop allowing the user to specify the exact number of balls and strikes in the situation. because this limited the data too much. But if there's a lot of data on a pitcher, this could be included for an even more robust understanding of the pitcher. Overall, situational pitching behavior has a lot to offer for both offensive and defensive users, and it is easily expandable and could be adapted for specific statistics that the user wants to see.